All right, hey guys, Mr. Kyle, Myers Mathematics, and let's just jump right into it. So today is continuing on with a series of Algebra 1 worksheets. This one is on sets of real numbers, so what I'm going to do is I'm going to work out the problem, show you the steps, and this one's going to be really quick because it's just the numbers and what kind of number system we've got here. So I think the easiest thing to do is just kind of just jump right in and then just show you from there like what number systems mean and that sort of thing, because a lot of times they just really don't talk about this kind of stuff. So anyways, let's go ahead and dive right in, starting with number 1. So the instructions here say name the set or sets to which each number belongs. Okay, so we want to start with the smallest and go from there, basically. So let's create a little key, because that's going to be the easiest way to do this. Now, this says real numbers, so we're going to assume that we're not going to go past that. There are some things after real numbers that we can talk about, and I don't think there are any of those on here. If I look, yeah, so they don't have any of that stuff on there. And you can see they put like letters for their answer choices because you started to see the answers down there. But we can kind of create our own letters. So there are natural numbers, there are whole numbers, there are integers, there are rational numbers. Okay, so rational, I'm going to put RA because real also starts with an R. And then irrational. So integer versus irrational, and then real, okay? And they're all mostly overlapping. So that's the other thing, is that a lot of these overlap. The only one that really doesn't overlap is irrational. Irrational is like its own total thing, but real numbers also include irrational numbers. So what they're going to probably do is use the fancy stuff, so like this and that, and then integers is actually with a Z for some reason. Rational is with an R, or no, it's not. It's with a Q. Let's go back. Real numbers is with an R. So rationals is actually with a Q. And you always put little double thingies on them. Irrational, it doesn't have its own numbers, so you just put like not Q, basically. And then real is R. So they're going to use letters that are all fancy like that. We can just use our own letters. We don't have to use all of their special letters, unless you really want to and you want to be all fancy. So I'm just going to include the regular letters and not the fancy ones on here. But you could always write the fancy ones too if you want. So this number right here is not a natural number. It's negative. So natural numbers can only be positive. Number 2 is a positive whole number. So that's a natural number. And I'm just going to go through the list and write which ones are natural first, and then kind of go down the list from there. So square roots, not natural, unless you can take the square root of it, I guess. Fractions, not natural. 6 is natural, though. 6 is natural. Oh, did I just put the fancy letter? I did. I'm using the fancy letters. Okay, so I changed my mind. So maybe I like to be fancy, and I'm going to put the fancy letters. But N for natural. If you need that key is up there. 0 is actually not a natural number. It's just barely not a natural number. But 3 is, and 14. Pi, definitely not. 10 over 11, nope. 475 over 325, no. It might simplify, but it's not going to simplify to like 2 or something, because otherwise it'd have to be like exactly double 325, and it's not. Right, twice 325 would be like 600 and something, right? So 650. So that's not going to simplify to 2. If the fraction simplified to 2, it wouldn't matter that it's written as a fraction. It would actually be a whole number, or a natural number, that is. Square root of 0 is just 0. That's still not natural. Fractions, not natural. Radicals, not natural. Actually, kind of, because 196 does have a square root, but it's negative, and we can't have negative natural numbers. So that's it. Okay. So actually, wait, hold on. Oh, I almost missed this one. Negative 16 over negative 2 actually equals 8 So that's a natural number. Okay, I think we got all the natural numbers. So just to show here, let's put natural numbers right here. Natural numbers are 1, 2, 3, ... all the way out to infinity. Whole numbers are basically just natural numbers plus 0. So whole numbers are just 0 plus the natural numbers. So basically any number that was already a natural number is also a whole number, because all whole numbers are also natural numbers. So we can put whole numbers on all of the answers that have n on them. Boom. And boom. And boom. Fancy W's. Also 0. 0 is a whole number, so let's not forget those zeros. Whole numbers. All right. So whole number, oh, there's square root of 0 is 0. So that's a whole number. And I think that was it. Okay. Yeah, forgot this one right here. Yeah. All right, so whole numbers. Anything that's a natural number is also a whole number. All right. So let's cross these off as we go here. Boom, done, boom, done. Okay. So notice I'm doing this in terms of number systems, not in terms of what number we're on, because it's actually going to be a lot faster that way. So next up is integers. So integers are basically whole numbers, but also negative whole numbers, right? So whole numbers include 0, but integers, which is with a z, so z is integers, would basically be whole numbers and -1, -2, -3, ... so on and so on. Okay? So everything that's a whole number is also an integer. So we can go everywhere we see a w, we can put a z. And now all of these negative numbers are also z's. So this is a z. That's an integer. It's a negative whole number. Anything that already has one of these guys on it, natural and whole number marks, or just a whole number mark, that's also going to be a z. So this is a z. This is a z. Anything that has that w or an n or both. 17/3 does not simplify. The square root of 30 doesn't simplify. Right. So negative, here we go. This one is an integer. That's an integer. That's an integer. 10/11, nope. -13, yes. That's a negative whole number. Okay. 475 over 325, again, that doesn't simplify. Not to, I mean, it simplifies, but it's still a fraction. There's no way to write that without writing it as a fraction, because it's not 325 over 325, which would be 1, and it's also not 650, which would be double 325. It's somewhere in between, which means it's a number that's between 1 and 2. Therefore, it's not a whole number. We don't even have to try to simplify this. You could simplify it if you wanted to, but you don't have to, because it's not going to be 1 or 2. It's going to be some number between 1 and 2, which shows us that it's not a whole number at all. All right, this is 0, so that's also an integer. This is also an integer, because the square root of 196 is actually 14, so that was tricky. -14 is an integer. -1, integer. 135 divided by -3. Okay, so if you want to see if that divides, one, you could use your calculator and just see if it divides. The other thing you can do is you can add up the digits and then see what that number is, and if that number divides by 3, then the whole number divides by 3. Meaning, 1 plus 3 is 4, 4 plus 5 is 9, 9 divides by 3, that means 135 divides by 3. And yes, this trick works on any number without fail. So this number does divide by 3, so let's go ahead and do that. 135 divided by 3, top number always goes in the box. I'm going to leave out the negative just because I know to put the negative in at the end. If you think you'll forget it, you can put a negative in there, but it's not super necessary while you're dividing. So that goes in 4 times without going over. 12, 1, 5. Okay, so I dropped down that 5 there. And 3 goes into 15 exactly 5 times. So this is going to be negative 45, which is an integer. Negative 45 is an integer. Oh, and forgot to put a z on this guy too. Okay, so I think we got all the z's. Yeah, it looks like we put a z on everything that we needed to have a z. Okay, so we're done with z's. All right, we're halfway there. Rounding off the back half here, rational numbers. Okay, so rational numbers, let's define those down here. So rational numbers, which is q. Don't ask me why, I don't know. I think I might have looked it up once and I thought it was a dumb explanation, so I just decided to forget. Rational numbers are basically any numbers that can be written as fractions. So can be written as a fraction. Okay? And that's an important word, can be, because that means that q is also, it's basically z plus fractions. But you're like, wait, but z is whole numbers and negative whole numbers. Well, yeah, but technically I could do this, right? I could go negative 1 over 1. Negative 1 over 1 is equal to 1. Since I can write it as a fraction, that means that it is a rational number. So every number that has an answer on it, if it has at least a z on it, that means it's also a q. So this is a q, double q thingy. This is a q. This is a q, right? So just q's on everything that already has an answer. Q's on everything. Let's just do that first, and then we'll go back and check what's left over. Okay? So q's on everything that already has an answer. That's a q. That's a q. Q for rational. Q, Q, and Q. Oh, I keep forgetting number 19. Okay. All right, Q's on everything. Cool, cool, cool. All right, so then we just need to figure out, okay, what else? Well, the square root of 30, I can't simplify that, and that cannot be written as a fraction. Okay, well, you might be like, oh, well, 30 over 1. Well, it's the square root of 30 over 1, though. You have to be able to write it without the square root as a fraction. So square roots don't count unless I can take the square root of the number. So that doesn't count. But 17/3, that's a fraction. Boom. Okay. 10/11, that's a fraction. Pi, not a fraction. And you can't write it as a fraction either. Sometimes you'll see 22 over 7 for pi. I don't know if you've ever seen that before, but if you have, that's just what's called an approximation. So 22 over 7 is pretty close to pi. It's like pretty close, but it's not pi. So pi cannot be written as a fraction. We don't want to label that with a q. This can, though. This is already a fraction. It can simplify. We don't need to simplify it, but it's a fraction, so q. That's a fraction. Square root of 77. Again, I cannot take the square root of that, so it's not going to be rational. I have to write it without the square root for it to be rational, which is why for number 16, for instance, I took the square root of 0. Square root of 0 is 0. I can write that as a number without the radical, which is why I could go ahead and label that as a whole number, and then as an integer, and then as a rational number. Okay, so I think I got everything. Oh, hey, did I do that? I did. Okay, so this is, there we go. Oh, what happened? There we go. Okay. So we have z and q for both number 18 and number 20. So I have q's on everything. That means I'm done with q's. Okay, cool. Done with q's. And actually, we're more than halfway done. We were more than halfway done when we got to z, because as you'll see, the real numbers are pretty easy once you figured out what's rational and what's irrational. So irrational is basically just the opposite of rational. So irrational, not q, is exactly what it sounds like. It can't be written as a fraction. Can't be written as a fraction. So that's like literally all it means. It's just the opposite of can be written as a fraction. And that'll leave us with real numbers here. And I'll go ahead and put real numbers on here so I can finish up this little notes section down here that I low-key put in. But real numbers are basically just rational and irrational. So you just add up the rational numbers, anything that can be written as a fraction, and anything that can't be written as a fraction. So plus not q, basically. Sometimes you put a dash, sometimes you put a little squiggly for not q, but yeah, basically anything that can or cannot be written as a fraction. Now, there are other numbers that are not real numbers, but if you notice at the top here, it said sets of real numbers. So we don't have to deal with stuff that's not real yet. And if you're like, what? There are other numbers? Yes, there are other numbers. There's actually a lot of other numbers, number types out there. But there's only going to be one other number type that you have to deal with, unless you're going to like major in math, and it's called an imaginary number, which is basically a square root of a negative. So that's really all that is. Okay, so irrational. Basically, since irrational is totally separate from rational, everything that doesn't already have an answer is going to be irrational. So this is irrational. And basically everything that doesn't have an answer, right? So this is irrational. That's irrational. What else? I think that's it. Yeah, everything else was already taken by rational numbers. So that's it. We're done with irrational. And that means we're on to real, which is basically everything. Everything is real. So just all of these numbers are real numbers. So you don't necessarily have to I don't know if you need to write it or not. But yeah, it would be reals on everything. So as I'm doing this, we'll go ahead and wrap up. This has been Mr. Kyle at myersmathematics.com. If you need tutoring, you can reach out to me at my email, mr.kyle@myersmathematics.com. Spelled the same way as the channel. If you haven't gotten an awesome free guide that I made a while back, it is called the 5 Math Mistakes That Everyone Makes and How to Avoid Them. It's a little guide on just the kinds of ways that you can miss math problems and how to kind of like identify what that is and then kind of like make a game plan for just not missing math problems the way that you're missing them. There's 5 different ways that people miss math problems. So check that out. That is free. You can just go to my website, myersmathematics.com, to grab that. And we're wrapping up here. I'm making another free guide here pretty soon that I'll let you know about. But it'll basically be calculator programs for different classes, including the SAT, the Math SAT calculator programs. So stay tuned for that. But hopefully this has been helpful. And again, this is Mr. Kyle. And if you haven't already, go ahead and throw a like on this video. Subscribe if you want to see more videos like this. And stay tuned for more Algebra 1 worksheets solved for you with the answer explanations.